Hi, in this video, I will be showing you problem number 41 of chapter 12, section 3. So find the scalar and vector projections of the vector B onto A. So this is problem number 41. So vector A is given to be 4, 7, -4 and vector B is given as 3, -1, 1 in the component form. So first let us look at the formulas. So scalar projection of vector B onto vector A is also known as component of B onto A, and it is given by the formula A dot B over length of A, which is written as component of B onto A. Then what is the vector projection? The vector projection of B onto A obviously is a vector. It is nothing but the scalar projection multiplied by the unit vector in the direction of A. So it is scalar projection multiplied by unit vector in the direction of vector A, which is A over length of A. That will be the unit vector. So if you write that, it is scalar projection, which is A dot B over length of A, multiplied by the unit vector in the direction of A is A over length of A, vector A over length of A. So we got the formulas, and then the vector projection is also written as projection of B onto A like this, and we will call it 2. So these are the two formulas that are needed to proceed with this problem. So let's start finding the scalar projection first. To do that, we need the numerator, which is A dot B. So A dot B is A1 B1 plus A2 B2 plus A3 B3. So if you multiply the corresponding components and add, you get 4 times 3 plus 7 times -1 plus -4 times 1. If you compute that, it's going to be 12 minus 7 minus 4, which is 1. So A dot B turns out to be 1. Then let's find out length of A, which is by the formula, which is square root of A1 square plus A2 square plus A3 square. So which is 4 square plus 7 square plus -4 square. If we compute that value inside the radical, we get square root of 16 plus 49 plus 16, which turns out to be square root of 81, which is a 9. So we got the numerator A dot B, we got the denominator length of A. Now we can find out the scalar projection of B onto A, which is also written as component of B onto A. This is the notation for that. So which will be A dot B over length of A, which is equal to A dot B we computed, which is equal to 1. And then a length of A turns out to be 9. So if you substitute, it's 1 over 9, which is the first part of the problem. Now we are going to do the vector projection. So vector projection by definition is the scalar projection of B onto A multiplied by the unit vector, which is in the direction of A. So scalar projection we already got, which is A dot B over length of the vector A multiplied by the unit vector in the direction of A is vector A divided by length of A. So this A dot B over absolute A from the previous part is 1 over 9. Then 1 over absolute A times vector A is written as 1 over 9 with times in the component form vector A is 4, 7, negative 4, which is 1 over 81 times vector 4, 7, negative 4, which can be written as 4 over 81, 7 over 81, negative 4 over 81 in the component form, that is projection of B onto A. Hope this video helps.